Hey, and welcome to our tutorial on algorithms. Today I will show you how to solve one of the easiest and top 100 questions in Leetcode called best time to buy and sell stocks, which falls into category of dynamic programming. First things first, this question has been mostly asked by Amazon, but for past 6 months it has been asked by various other companies like Adobe, Apple, Microsoft, and some other companies like so. Our primary language of choice is going to be JavaScript, and we will explore one of the top solutions for solving this problem. So without further ado, let's dive in. Okay, let's go through the problem first. You are given an array of prices where prices I is the price of a given stock on I's day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in future to sell that stock. Return the maximum profit that you can achieve from this transaction. If you cannot achieve any profit, return 0. So let's see some examples to further understand this problem. In the first example here, we have our prices array like this, and our output is 5. So in the explanation, it says that if you buy at day 2, where price is 1 as it is at the lowest of all, by the way, and sell it on day 5, where price is 6, we could make 5 units of money, which is the highest profit in this dataset. And also note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. Second example, seems like with this dataset here, we cannot make any profit at all because as we are moving forward in our array, the price is decreasing, and that literally means that if we sell, we are going to lose money and we better not. So how we can solve this issue? The answer is really simple here. If we take a closer look into our first example and break it down, we have 2 tasks. First, we need to keep track of our lowest price that we can buy. Then we need to calculate our profit in next days in order to see if we are making some good money out of it. Since this is a dynamic programming problem, generally we need to break this apart. We already have defined our tasks, but for tracking the lowest price of a stock, basically what we need to do is comparing values with next one in our array and update our tracker variable. The same goes for profit. If we are making more profit today rather than yesterday, then we might update it. But the gist of what I'm trying to say is if we have met a certain condition, we will update our metrics and move on. Let me explain how. We will have 2 variables to keep track of our lowest price and profit. Since we need to know the lowest price, we need an initial value to compare our current value in array with it. And again, since we are tracking the lowest value, we need something opposite to whatever low value that we could have above 0 in general in order to win this comparison here. Best choice for us will be some number that is really big, something like infinity. And for profit, at the beginning, we don't have any profit, so it will be 0. Now, if we iterate through this data set, first iteration of our array, we have 7 as price. Which one is a smaller value now? 7 or infinity? Of course, 7 is smaller. And our profit is 0 because the question forces us to sell in another day. We will update both here. Second iteration, if we have 1 as price, which one would be smaller now, 7 or 1? So 1 is lower and we will update our lowest price, and our profit is going to be still 0 because we just bought our stock today. Third iteration, which one is smaller? Our current value of 1 or 5? Of course it's still 1, so we need to update that. And since we are allowed to sell now, how much profit we would get if we sell? You are right, by subtracting current price of 5 from our buy price, we will get 4 units of money in here. Fourth iteration, which one is smaller, 3 or 1? Still 1. How much money we will make if we sell? 3 minus 1 will become 2. So we better not to sell in this day and subsequently not update our profit in order to still represent yesterday, which we were making 4 units of money. Moving on, iteration number 5. Which one is smaller, 6 or 1? Is still 1. How much money we will make if we sell today? 6 minus 1 will become 5. Now our last record for making profit was 4. this record is bigger than that, so we need to update our profit at this step. And finally, last iteration, again, which one is smaller, 6 or 1? Still 1. And finally, how much money we will make if we sell today? 4 minus 1 will become 3, which is less than our latest profit, and that means that we will not update our profit variable in this case. Basically, now we have our max profit of 5, which is right there, and that was exactly stated in the example earlier. So we can easily return that profit from our function. So let's implement the code for this solution. Here we are in Leetcode to implement the solution. As of our thought process, first we will create our two variables called lowest price, which is going to be infinity, and second is going to be our profit variable, which is 0 at the beginning. Second thing that we need to do is iterating over our prices array. We are going to do a simple for loop for that, like for let I equal 0, I less than prices dot length, and I plus plus. Inside of this for loop, we are going to be tracking our lowest value in array. Remember that we need it for calculating our profit. We basically can say if prices at index of iteration is less than our current lowest price, this variable here, then we need to update our lowest price, right? Lowest price is going to be equal to or current price because it's lower. But there's a better way and shorter way than that. We can use a trick here. Something like lowest price is going to be mass.min, and one of the elements is going to be our current lowest price, and second one is going to be prices.I. Basically, this is going to choose the lowest value between those two variables, and that's more simple. Now, we need to keep track of our profit. Again, we can do something like our current profit is less than prices.I minus lowest price. Remember that this is like inside of a parenthesis here. If that is the case, we can update our profit variable, which is going to be assigned to this. But if we use the same trick above, we will end up with something like our profit variable is going to be assigned to mass.max of our current profit, or this expression here. Whichever is biggest, just assign that to the profit variable. And finally, at the end, we are going to return our profit value. Now let's run our smoke tests. There we go, everything is passing, and if we submit, there we go. We have this 92 millisecond of runtime and beat 66% of memory. So we are in a good shape. So what about time complexity? Literally, we are doing not that much here. We are just having a for loop over our prices array. So we will have O of n time complexity here, where n represents the length of the array. For space complexity, again, we are not doing anything interesting here except creating two variables. So it will be O of 1 or constant space complexity. With that, I can say thank you for watching, and if you like this video, please like, subscribe to the channel and write a feedback if you want. Finally, hope you enjoyed this video and see you soon in the next one.